Alright, for the next video we're skipping ahead to section 12.6. The last thing we did in class was 12.2, but there's some stuff in there that you're not going to see until Algebra 2. So for now we're going to look at permutations and combinations. These all utilize factorial, so the first topic to cover in this section is what is a factorial? Something you might have seen in your previous math class. The symbol for it in math that we use is an exclamation point, and it's a shorthand way of writing a multiple product of numbers. So a factorial means you multiply that number by all the integer numbers smaller than it all the way down to 1. So the formula looks kind of gross when it's written with these n's and n-1s and n-2s, but in principle using it is actually very easy. So if you have 4 factorial, for example, that would be 4, which is the first number, n, multiplied by, the next one is n-1, which is 1 smaller, so 4 times 3 times 2 times 1. And of course, 4 times 3 times 2 times 1, if you multiply it out, you get 24. So like 10 factorial, for example, would be equal to 10 times 9 times 8 times 7 times, and I'll just write dot dot dot, and you go all the way down to 1. Okay, and then you can see these numbers are going to get really, really big very quickly. So 10 factorial is a huge, huge number. 20 factorial is so big it'll barely probably fit. Let me look at my calculator real quick. 20 factorial. There should also be a button on your calculator that will let you do factorials. If you can't find the button on your calculator, then we can do it in class together and try to see where that is. Maybe some have it, maybe some don't, but I don't see it on my calculator here at home. But we'll look in class and make sure that everyone knows how to do a factorial on their calculator before you start this homework. Okay, so the two formulas for probability that utilize factorials are permutations and combinations. So both of them have a similar format. The symbol you write is subscript n, then either a capital P or a capital C, and then a subscript r. An alternate way of writing it is the P or the C and then parentheses n and r. So this is function notation. It's a permutation function, and it has two inputs, n and r. So n is the total number of items, so n is total, and r is the amount that you're selecting. So for example, if you have 10 friends and you can only take 3 of them with you on a trip, then r would be pick 3, and n would be the total 10. So 10 pick 3 is how you pronounce it. So n pick r, n 10 pick 3 for this example. Now, the formula here, it deals with factorials, and you're going to look at factorials of the total number of people you have. That gives you the total number of options. And then in the denominator you do n minus r factorial. That subtracts out based on how many people you want to take with you or how many you're selecting out of your group. So this formula here is what you're going to use. So this one is very, very critical to write down in your notes. Put a big box around it, put some stars by it, and memorize. Okay, combinations are very similar. So combinations formula is exactly the same as permutations formula, except it has this added little factor of r factorial in the denominator. So what's the difference, you might ask, between combinations and permutations? So combinations is a set of ways to pick items from a set if the order does not matter. So when you're picking them, it doesn't matter which order you pick them in. All that matters is which ones come in the set and which ones don't. Permutations, on the other hand, is picking a certain number of items out of a set, but when the order that you pick them matters. So for example, if you just said, I want to take some friends to the movies, and you want to pick 3 of your friends to take to the movies out of 10 friends total, that would be combinations, because you're just picking 3. But if you then wanted to actually get to the movie and sit down, you have to sit down in a certain order in those seats, and so that would be an example of permutations. So in both cases, you'll say n choose r or n pick r for combinations and permutations. Okay, so problem solving tips. There's usually more than one way to solve probability problems. You can use these factorials and formulas for combinations and permutations, or you can do a step-by-step sequence. And once we get to the examples, I'll show you exactly what I mean by a step-by-step examination. But a lot of probabilities, it's like 2 or 3 events happening in a row, and you can find the probability of each one and multiply them together. Number 2, be sure you're familiar and comfortable with your calculator use. Again, especially the factorial button, or doing factorials long ways, which I don't encourage. So let's make sure we can all find the factorial button on our calculator. Showing the setup is important. So again, when you're using these formulas, it's really, really critical that you show what is n, what is r, which of the two versions are you using, and then plug in your numbers. And lastly, combinations, order does not matter. Permutations, order does matter. And that's just something to remember if you don't already know these words. All right, let's see what it looks like when we apply it to an example. Identify as a permutation or combination. So if you're putting 16 songs onto a CD, then the order matters, so this is a permutation. Choosing 3 sports to play at a camp, the order does not matter, you're just picking a group of 3 total sports to play, so this is combinations. Choosing a batting order for kickball, I mean the word order is right there in the problem, so that's an indicator that when you're putting things in order, then it's going to be a permutation. Okay, school play. Joseph, this is a separate problem, it's not part of the same directions. Joseph and 8 friends are attending the school play. How many ways can Joseph and his friends sit in 9 empty seats? So here we've got permutations, so we've got n permutations for R. Now we've got 9 empty seats, so there's 9 total people, and we want all of them to sit in the empty seats, so 9 pick or permute all 9. Okay, so if we go back to the formula for this, we see the formula is n factorial divided by n minus r factorial. So this is going to be 9 factorial over 9 minus 9 is 0 factorial. Here's something that I didn't mention in the previous slide, but is very, very important. 0 factorial is defined as 1. So make a big deal about that. 0 factorial is equal to 1. So it's okay to have 0 factorial in the denominator because it's defined as 1. So this is just 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And whatever we get from all that is the number of different ways that Joseph and his 8 friends could sit. So again, let me type that on my calculator just to clarify. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I get 362,000. So this number is probably bigger than you could have predicted. 362,880. So next time you go to the movies with a group of friends, and there's 9 of you, try to think about how insane it is that there's 362,880 different ways you guys could arrange yourselves to sit at the movies. Now, as I said before, I wanted to show you kind of a different way of looking at this kind of problem, and that is by taking the problem step by step. So imagine you have 9 empty seats. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you want to figure out how many ways there are for you guys to sit down. In that first seat, there's 9 people available to sit there. So any one of those 9 people could sit here. So here there's 9 choices for who sits there. But once that first person has sat down, there's only 8 friends left. So whoever sits next to them, there's only 8 options for who's going to sit there. And once those 2 people have sat down, the next seat there's only 7 people available. And then there's only 6 people available. And as you can see, by filling these seats one at a time and thinking about how many people are left, you obviously get the exact same thing as using the formula. But this is mentally a very different way of thinking about it. You're saying, step by step as I work through this process, how many options do I have available at each step? And then you multiply those options together to get the total. So I think it's nice to think about them in 2 different ways. Okay, a couple more examples. Passwords. Any letter or number can be used in a 4-digit password with no repeating. What is the probability that the first 2 digits are numbers and the second 2 digits are letters? Here's a great example where it's a better way of looking at it by just writing down 4 blank lines and then seeing how many choices you have for each spot. So it says the first 2 digits are numbers. So how many different numbers could I put here? Well, the options are 0 through 9, which means there's 10 options total. So that first number, there's 10 different things it could be. Then the second one has to be a number also, but it says no repeating. So that second one, there's only 9 numbers left, because whichever number I used here, I cannot use here. Then the last 2 digits have to be letters. So the first one, there's 26 letters to pick from, so there's 26 options. And then the last one right here, once you've used one of the letters, there's only 25 letters left again, because it says no repeating. So if you think about it like this, you're not really using the combinations and permutations formulas per se, but you can get to the answer much more quickly. So if we multiply this out, 10 times 9 times 26 times 25, we get 58,500. So instead of doing it this way by looking at 4 steps one at a time and figuring out what can go into each one, we could try to do it using the combinations or permutations formulas. And if we were to do that, we would group these first 2 pieces together, and there we would have 10 numbers, and then we'd be looking at a permutation where we just pick 2 of them. A permutation because the order matters, like if it was a 1 and then a 2, it would be different than a 2 and then a 1. And then for the second 2 numbers, we have 26 to pick from, and we're choosing permutations again of just 2 of those 26 letters. So we're picking 2 of the 10 numbers and 2 of the 26 letters. We're putting these in order at the front, these in order at the back, and of course that will give us the same thing. So 10 permute 2 is this 10 times 9, and then 26 permute 2 is going to be this 26 times 25. So whichever way you think is easier to visualize, you can use. Here we're evaluating each expression, so this is just basically plug and chug, practice using the formula. So combinations formula, if we have n choose r, n combined to r, we get n factorial divided by r factorial times n minus r factorial, and that's going to give us 11 factorial divided by 2 factorial times 11 minus 2 is going to be 9 factorial. Now there's a cool trick when you're doing this. 11 factorial means you multiply all the numbers 11, 10, 9, 8, 7, 6 all the way down. And then 9 factorial means you multiply all the numbers 9, 8, 7, 6 all the way down. So 11 factorial over 9 factorial reduces to just 11 times 10, because everything from 9 onward is going to cancel out in the top and the bottom. So times 9 times 8 dot dot dot, and here in the bottom we had 9 times 8 times dot dot dot. So these pieces cancel out, but this 2 factorial is still right there. So 11 times 10 is 110, divided by 2 is 55. So when you're doing the formulas for combinations in particular, a lot of times big portions of it will cancel out. That's important to remember. Okay, that's it for our examples, and I'll see you in class.